I hope you still have enough energy at the end of this day to listen to my presentation, and I will develop a little bit on technology, innovation and social responsibility at this seen from two perspectives. The first one from the European Physical Society, which is a large organization, as you will see, and on the other side from the IBM perspective, and I will develop some of the key features which might change our life in the future. This is the cognitive computing or the cognitive era, the Internet of Things, and the future will be worn. It means the wearable electronics which will be coming up. We heard about the great invention in the 20th century, the plane, the antibiotics and the transistors, and you will see that the transistor or the semiconductor technology still will have a very, very strong impact on our life. So, some of the people of you might recognize this place here. EPS was founded in 1968, that means 47 years ago, here in Geneva, in this place. And this was under the work of Gilberto Bernardini that this organization started, especially with the aim to strengthen the scientific collaboration, to bring the scientists to collaborate as close as possible in order to make their positive contribution to the strength of Europe, cultural unity. This was at the time of the Cold War and the beginning of Europe. And you see that the scientists have done a great movement since then. At the time, there were 62 individual members in this society, representing 20 national societies. Today, EPS is at the same time an umbrella organization which represents 42 member societies from all the countries which are in blue on the map that you can see, and representing by this way about 130,000 physicists. On the other side, we are also a learned society, promoting scientific excellence, and we have individual members, as you can see, 3,500. It's not very much, but I mean, we are moving up at least. We have 40 associate members. You can see that CERN is one of them, DESI, the IOPP, which is the publishing organization of the Institute of Physics, ESA, PSI, IBM, and so on. And we have 22 collaborating societies, which makes us very much multidisciplinary. And the headquarters of the EPS moved from Geneva to Mulhouse in France. The roles of EPS is, of course, are multiple. And as you can see, it's certainly to enhance cooperation. We heard before how important it is to cooperate between national societies, national countries, and also the different societies. It is also to define for scientists areas of common interest, such as funding fundamental research. I think we all agree that this is something which we have to work on in the future, to be sure that funding fundamental research is something which is kept. We have also to promote science and innovation programs. We have to promote education. We heard this also before, and equal opportunity. Outreach, how we talk to the public, how we present science, and we heard it also at the beginning of this meeting today from Rolf Heuer, how important it is to have transparency for promoting science. Outreach, promotion of talented students, this is the future, physics students, networking, links between industry and academia, this is what you mentioned before, it's also very, very important, and I am, as a physicist from the industry, trying really to promote this aspect. Large-scale infrastructures, that's what we hear at CERN. And finally, very, very important is the physics for development. We have to think about other countries which don't have the means to have science education as we do here. Finally, what we want to do is to decide on strategic initiatives at the European level, trying to maybe help in formulating the policies, and you can see on different areas like research, energy, environment, ethics is a very important issue, and also to be present in Brussels. Some of the policies, you know, we are very broad, as I said, a very broad base of scientists and physicists, and we represent a very strong community. but we have to do better. We are not as strong as the chemists because they represent the chemistry industry, but the physics is everywhere. You will see this later. In fact, we have in some way to understand all the issues which will be presented also to the politicians, especially on the different items that you can read here. Science and research, education, energy environment, physics and society, physics and economy, European cooperation and international cooperation, and you see a few logos of very important organizations we are collaborating, like European Research Council, Euroscience, and of course also European Commission. The activities of EPS are multiple. I don't want to expand too much. Of course, we want to promote scientific excellence. There are conferences and prizes and grants. We want to have community services. I mean, especially equal opportunity is very important, and gender equality has to be very much promoted. Integration, east, west, north, south. Physics education, we heard, is one of the key pillars of what we have to do. The future in the hand of the students which are coming up in the future, and we have to look at how we can specify more the curricula for the bachelor's, master's, and doctoral studies, and we have been very strongly involved as EPS. We are also very strongly involved in AU projects which are related to education, and you can see HOPE, Horizon for Physics Education, Inspiring Science and Education, and also some other one which are related to LIGHT 2015, which is the International of Light this year. And in terms of publication, of course, we are very active, but I think I'd like to just to mention the outreach, the International Year of Light. You know all of this. EPS has been one of the co-founders of this great program, which is spread all around the world now. And also, as another outreach activity is the so-called historic sites programs. This is the way you promote information to the public by telling this is a very important place where physics has played a role. It can be a place like the Einstein House in Bern, for example, or here I give you another example. This is the 600 megavolt synchrocyclotron, I mean the accelerator for proton here at CERN. What is important also is to make statements. As an organization, we have to make statements of things which are very important. Bibliometrics. How to judge your peer by the bibliometrics indices. This is something important. The opportunities in Horizon 2020 and also managing the transition to open access, the publication to open access is a very strong issue. Maybe not as much in high energy physics, but in condensed matter physics, for example. The impact on physics on AU economy, I will come very quickly to this, but I think it was very important, again, look at the second item, European energy policy and global reduction of CO2 emissions. We published a short report, our group on energy, supporting all the views that we heard before in the introduction. And I think this is very important to promote and disseminate the information. And we send even this to the Pope, to the Academy of the Vatican, and so on. Now, physics and economies. You won't believe it, but physics, we made a study between 2007 and 2010 by the Center for Economics and Business Research. It was asked by EPS to do this. And we found that physics-based industry has a tremendous impact on the business in Europe, on the economy in Europe. And how you define, of course, physics-related economy is given in the square, in the red square, you see electrical, civil, mechanical engineering, design, manufacturing, transport, medicine, and so on. And in fact, 13% of the jobs are created, are jobs which are physics-related. 30%. It's in fact, in 2010, 15.4 million of jobs were created related to physics, and 50% of the revenues, of the total revenues in Europe, was related to physics projects and programs. Now, let me just go on a debate on the research culture. We heard this already before, but I think it's important to look at the fact that we have to encourage and support the scientific research is high quality, rigorous, original, ethical, and valuable science. This is exactly the words that we heard from Rolf Heuer at the beginning. We have also to be sure that the assessment by the funding agencies are not taking away the freedom of the scientists in some way, because this is the way the funding bodies will affect science, how it is done in the future. This is something we have to be very much aware. Dissemination of science, as I said before, is very important. And again, we have to take responsibilities as scientists and encourage good practice. This is something we heard also before. Now, scientific discoveries can be nice for curiosity satisfaction, but it has also to have an impact, a good, hopefully, impact on our society, especially to nurture technological application and innovation. And also, we have regularly to look at the assessment of our societal and economical impact in research. Now, let me go to the perspective from IBM, which is slightly different. If you remember at the end of this talk, the acronym CAMS, C-A-M-S-S, which is meaning cloud, analytics and big data, mobile, social networks, and security. These are the keywords which are coming up now for the information technology companies. And I will expand very quickly on the cognitive era, the Internet of Things, which is called also sometimes the Internet of Everything now, because we have to move. These are new keywords, and what I will say, the future will be warm. So first, IBM, as you can see, it's a very, very broad organization, which is a profit-making organization on one side, but it has also a very large research organization, which is spread over 12 different labs worldwide, as you can see. And there is maybe a strong statement from the IBM to say the world is our lab. It shows you how globalized we are today, and all companies have to do this nowadays, and we heard this. And you see that IBM spent about 6.2 billion in research and development in 2013, which is quite a large amount of money. Now, it has for a long time been very strong in innovation. You know that all the technology, information, software development, the hardware development have been very strong. And on the other side, IBM came out with a so-called smart planet or smarter planet. What can you do to improve smarter transportation, personalized medicine, analytics, smarter cities? How can you improve fluidity in the traffic, for example, in the cities? And this has led, of course, to many recognition for IBM. So now, the cognitive era. It is what we call how humans and machines are forging a new age of understanding. It means the symbiosis between the human and the machine. Cognitive computing means, in fact, systems that can understand, learn, scale, and reason with purposes and interact with human naturally. And if you look in the past, we had three eras before. I mean, the two eras before, the tabulating era, when all the things were done mechanically. This is between 19 and 1940 until the discovery of the transistors. And then we get to the programming era with the digital computers that we know nowadays. And finally, the cognitive era, which is the new one, where we have so-called augmented intelligence. The computer is helping us to make decisions and to make assessment about future. And IBM has the so-called IBM Watson. It's a new business unit which is based on a supercomputer which can recognize, which can listen, and which can have a very strong cognitive understanding of things. And it delivers so-called cloud-based guided analytics and data visualization and predictive analytics. And this is something which is really coming very strongly today. And why is it so? Because we are generating so many data. And this data has to be analyzed. And in fact, IBM is recognizing that the data is the new resources today. And I think CERN is one of the main producers of data, which are certainly structured. But a lot of things are coming from unstructured data, and you can see healthcare, the government and education data, which will grow, utilities data, and media data coming from video films, images, and audios. All this are producing a tremendous amount of unstructured data which will need to be analyzed. Now let's go to the two final things I want to talk, the Internet of Things, which is a huge market. You can see that, in fact, it will reach 22, 23 billions by 2020. All the wireless information, Internet of Things, all the sensors which are related to this will produce a market which is worth 12 billions by 2020. The Internet of Things is everything which is interconnected via the Internet, of course, which was invented here. So you see that there are, of course, very strong paradigm shifts. We need to wearable device to have very highly performing electronics, which is low power design system or very highly integrated system, and they have to be cost effective. So finally, everything will be working for the other clouds. You all know and you all heard about the clouds. You have platform for sales and services, you have software services, and we are all pushed into this new mode of action. And I believe that the cloud, and combined with the Internet of Everything, will be delivering a lot of new convenience, which we'll call maybe the cloud of everything. Anyway, you can always come with keywords the way you want. Now, just to finish, the future will be worn. That means we will all be connected by what we are wearing. And this will be a technology which will be exploding because the performance of the devices, the electronic devices, will be always better and better, and so that we can, and smaller, and there will be so much interacting that we will have, each of us will be wearing something like this. And I can show you that, again, the global sales for wearable will be about $30 billion dollars by 2018. Huge market. But today's market is basically related to fitness and wellness, which is increasing 30% per year. I mean, all of us, you know, we like to hear our beat heart and so on. So we have one of these necklace or some kind of a band that we can put around our arm. They are also used for healthcare, medical, infotainment, which is, of course, everything related to information and entertainment, industrial and military. But there are K inhibitors. I mean, things will be not so easy, and this is what I show you here with the power. It has to be very low power systems. We need to have a very large network bandwidth, so we might be competing with the organization of the climatology. Pricing and aesthetics, you need something which is nice and simple to use and cheap. And finally, it has to be a very easy interaction. If you have a single button, you have to be sure that you can combine this button with many multifunctionality, especially also having new accessibility by voice and visual interface. So you see some examples, and I show you on the right some trousers which are made with fabrics which is intelligent, producing for example, piezoelectric fabrics which can generate electricity. So finally, my conclusions is that thanks to the cloud and to the Internet of Things, the future information technology will become more instrumented, interconnected, and intelligent. The market of wearable technology will explode, and the new cognitive computing tools will be needed to treat the ocean of unstructured data. But there is a but, and this is what I like to bring you. What impact will this have on our life? On the development of a fair and peaceful society, respectful of its environment and of the planet resources, because all these electronics things will generate so much garbage that we have to take care of. So it's where we have also to take more responsibility as consumers. So hopefully this will tell you a little bit that every aspect on developments like the IT is proposing has also a backside. The backside of the metal, which is, of course, the pollution, the impact on our environment, and also maybe on the global warming. Thank you very much.